think it's safe to say good evening instead of good afternoon. Since I've known about 80% of this room for the last 20 years, worked with them in various capacities, I know the worst position you can be in is standing between this group and the cocktail hour. So I've eliminated about 40% of my slides. I have a backup crew in defense consisting of Rich Chernock, Luke Fay, and Madeline, who are going to be up here very shortly. So they'll help me through this. We were actually going to eliminate that one, but why are we eliminating, or why are we looking at advanced emergency alerting? Well, we tend to rely on our cell phones, but they at the most needed times tend to be useless. So without going into a lot of detail about various events, let's look at advanced emergency alerting. It's really the next step in a robust delivery of emergency alert information to the public. This work has evolved or developed out of the work we did in mobile EAS through the coalition and the implementation team. And it's an application that uses the robust capabilities of Atsc 3.0 to deliver alerting information. It's a real opportunity for the broadcasters to provide a more robust and reliable public warning system. Not only just the alert, but also backup information, what to do before, what to do after, and it's all independent of the wireless network. It leverages the broadcaster's role as a public information provider using their quite robust and resistant to disaster-based facilities. For the wireless folks, it offloads traffic from the systems that would normally be tied up for browsing and video traffic and allows them to do what they do best, which is voice communications. It's an opportunity for the broadcasters to enhance the station's brand for weather, for news, for essential information during times of emergency. Provides a pipeline for extensive information beyond simple text alerts. So this would be rich media content that provides detailed information. Again, what to do before, what to do during, and what to do after. And I think very important to the 3.0 process is it creates a public policy that supports transitioning to ATSC 3.0 and eventually unlocking mobile devices for broadcast TV reception. One of the challenges is, are we replacing or are we supplementing the current EAS system? If you talk to the Bureau Chief at Homeland Security at the FCC, he will tell you that the EAS system is broken, and that I think in the long run, from a regulatory policy, it will be ultimately replacing, but in the short term, it will be supplementing. EAS exists in the US, in Canada, and a number of other countries. The rules for that are found in Part 11 of the FCC's rules. There's also an IPAWS cap profile that supports cap-based messaging. There is some elements of the 21st Century Communications and Video Accessibility Act that could very easily relate to EAS applications. In Canada, you have even some more stringent rules, and since we're looking at a standard that would be used in other countries besides the US, we have to be aware of their activities. Here in the US, the current EAS protocol has a header which consists of a series of bits of information, as you can see in the lower part of the picture, a two-tone alert signal that precedes the actual alert message, which in television is both a text message as well as an oral message. And if we're going to supplement, we have to be able to provide that information as well as the supplemental information. There's a bit of a misnomer about CAP, Common Alerting Protocol. Not all alert messages are CAP-based, but there is quite a bit of CAP activity that takes place both here in the U.S. and Canada. There is not a lot of harmonization between the CAP protocols that are used in those two countries as well as the other countries that have gotten into CAP. So one of the challenges will be to harmonize a CAP-based system. So what's required? Well, first of all, from the output standpoint of emergency alerting, the TV station must encode or send information that is rebroadcast from the EAS system. There's an attention signal that has to be transmitted. There's a display of the alert, both visual and an oral part of the alert, and there's an end of message string that is sent. The encoding and transmission has to follow the FCC Part 11 rules. The alerts can be presented with not only the oral information, but there's also a geo-targeting method, primarily based on FIPS code here in the US. There's, of course, the crawl. Where the crawl is positioned is more stringent in, for example, Canada and some of the other countries, whereas we have looser language about positioning of the crawl banner and the information here in the US. And no multilingual requirements at this point, but in Canada there's already a bilingual requirement. So from the current and near-term position on EAS, the broadcast EAS will continue for the foreseeable future based on the AFSK tone-based messaging. CAP will continue to grow, and that will be fueled by the wireless emergency alert system. And there are, within each state, EAS plans that have different assignments, different schedules, et cetera, that broadcasters have to deal with. So let's look at the development of advanced emergency alerting within ATSC. First of all, it's a complete ecosystem issue. Spans all three layers. The development includes S32, 33, and 34, plus some work in some of the ad hocs. There has been a TG3 Advanced Emergency Alert Focus Group that Rich formed, and it consists of people from across the three layers, as well as some other industry folks that make up that team. And that is in addition to the implementation team, whose job will be to test and implement the system once it is standardized. So let's look at some of the features. First of all, we're designing the system to reach all types of receivers. It has to be able to, on a very robust basis, wake up receivers that are in a sleep mode. The alerting messages will be sent via an XML file-based system, and that will be delivered by the EAS receiver processor, which is a device that already exists in stations, but in many cases will have to be modified to output the correct format. Some of the products out there already have the capability, and in fact, we've demonstrated that with mobile EAS. The alert messages are capable of targeting receivers in specific geographic locations. Of course, that's based on the fact that the receiver itself is implemented and has that capability. And we believe that the process of how the receiver reacts is going to be one that's going to have to be tackled by the CEA receiver working group. And we've already established the fact that there'll be a liaison between our work and the work that takes place in that working group to set up some receiver requirements. The Advanced Emergency Alerting System supports the delivery of multiple types of rich media content that will support the enhanced alert. This can either be file-based or stream-based, and it would include things like weather radar loops, evacuation route information, could be a live news segment, could be instructions on what to do before, during, or after an event. And much of this content will come from the station's news and weather services, as well as from official agencies. There'll be a user guide, which provides alerted consumers with a self-directed method of selecting the appropriate rich media that is right for them. And that rich media will be there for them to select and go through and review and go back to as long as it remains in the system. This rich media information will be versioned and will also be sent with an expiration so that as new versions come out or the time requirement for the information is no longer there, that it will expire and go away and not be collected on the receiving device, since that's where it's stored. So basically, the alert information comes in via different channels, many different channels into the station, goes into the processing device, which filters and converts the information. Today, it outputs text files that can go to character generators, which do the station interrupt and display. But in the future, that could be an XML file that drives the system that displays alerts on the receiver as opposed to interrupting the program feed from the station. It would also output the appropriate audio, can do text to voice conversion and create audio files that can be sent as well. So one of the things that we came up with during our process of MEAS, and we had a lot of great work that was done by the folks at Trevini, was creating something called the Content Manager. The Content Manager is the next step after the AES or EAS receiver processor. It's a link between that and the distribution system, and it's where the station's rich media content can be associated, and also those types of events that might require some newsroom or station management intervention prior to release, because not everything has to flow real time. Only certain types of alerts have to flow real time, where that could be done through a user interface likely to be part of the newsroom system. So we actually have a prototype system up and running thanks to the folks at Trevini Digital, and have demonstrated this in numerous occasions. So just to look at, here's a portable or handheld device. In this case, we get an emergency banner. The banner is a touchscreen activated device which allows us to drill down to a guide, and the guide shows us the status of information, shows us whether it's loading or there, and allows the user to select and go in and pull up various types of alert content. Here we see radar loop, we see an evacuation map, we see some textual information on what to do. Video clips, such as the radar loop, can be updated on a, let's say, every 3-minute basis or more frequently. Stills can be sent. In a lot of cases, newsrooms acquire stills from the various viewers on events that have just happened, and those can be relayed and sent out. HTML pages can be captured from the internet via the station and then sent as an HTML file, so that, for example, in this case, Duke Energy has a listing of all the outages on power in a given area, this during a time of a hurricane, and allows the user to go in without having to, again, pull up the browser and rely on the internet to actually get to that content. And again, geo-targeting. The Weather Bureau, by the way, is not necessarily in sync with FEMA and the other alerting groups. They tend to use polygons, but it doesn't translate necessarily directly to the FIPS codes. FIPS will probably be the standard, but that is not a decision we have to make. It's one that the alerting agencies have to work on. So again, what's the road to implementation? Well, first of all, we have to complete the work within 3.0 that supports advanced emergency alerting, and that's TG3, specialist groups, ad hocs, the focus group. We have to work with the CEA receiver working group give them input on what the expected receiver response will be to the messages that we send. And there's work also going on outside of ATSC on the part of the various groups such as NAB, APTS, the I-Team, broadcasters, and there's a policy team that has been put together for advanced emergency alerting that has been working with the FCC, FEMA, NOAA, and some of the other agencies that are interested in the work that we're doing. So let's take a look at where we are in the specialist groups. Luke, you want to come up and tell us what's going on in S32?
Okay, I know what you're all thinking. It's like, God, when does this boot camp end? All right, 5 minutes. How about that, 5 minutes? Hold on. In 32, there's two aspects of it. There's work that's already been completed, and then there's work in progress. The completed work is in the candidate standard with a bootstrap signal. We support EAS with a special wake-up flag. You can see it there in the table of 6.2. That's the first one listed there, EAS wake-up. It's 1 bit. Excuse me. And then the work in progress is what are we going to do with that? How are we going to send the actual alerts? And that's what we're dealing with right now. There's a preamble and a framing piece that are being looked at to carry information, and it's a big question, where do things lie? So there's a whole list there. There's a CAT message. There's an EAS channel or a dedicated pipe. You know, we have to carry the weather maps, evacuation routes. Should there be low latency, et cetera, et cetera. So that's the work that's in progress. Next. And as a little window into the physical layer, this is borrowed from, well, you can't see it there at the bottom, but basically this is a slide from LG. The document number is S32-3-370R1, just to give them credit. But it gives a good view of where EAS lies. And in the physical layer, we have a lot of data pipes, which we've been saying all day long. You can have a lot of varieties in there. But at the bottom on the left-hand side, you see that red arrow, and it points to EAS block. There's two pieces. There's the advanced content, which is weather maps and whatnot, and then the universal alert. That's where the CAT message lives. And all that EAS block is going to be shoved into what they call an EAC. This is just an example. EAC is emergency alert channel, and that outputs through the physical layer. And those sizes, the sizes of the pipes can vary depending on how much emergency information is actually to be sent. And the scheduler actually controls the sizes of the pipes. But that's about it from S32. You can see what we've done and what we have left to do.
Okay, thanks, Luke. Rich is up representing S33.
Okay, so as I said yesterday, this isn't even work in progress. We haven't started yet. So this is all speculation on my part. If I got it wrong, give me the blame. But we've got experience doing this before. We're basically the plumbing layer. And this is quite a bit similar to what we did in MEAS. We're also building a framework that should support all of this stuff with very little additional work to make advanced emergency alerting work. So the activities I think are going to happen in S33-1, essentially the transport. We are going to need some extra signaling for advanced emergency alerting. There's got to be something that indicates this is an emergency alert and so on. It should be simple additions to the signaling that's going into place already. We got to deliver that signaling. That's probably going to be very similar to all the rest of the signaling, delivering the same mechanism. There's rich media. These are files. We have file delivery in the plate already, so again, it's going to be very similar. And there's streaming media. So I think the only real extra work is the extra indication of signaling for advanced emergency alerting. And in Madeline's group, S33-3, as she mentioned, there is going to be support for companion screens. So what's happening when you're looking at your little tablet and an emergency alert comes on, you're not quite focused on things, we want to be able to move that alert to that screen. So as I said, we haven't started, but we don't expect that the work is going to be all that difficult. It should be really an add to what we're doing already.
Okay, thanks, Rich. Madeline, S34.
Similar to S33, S34 has not started working on this yet, and what you see on the screen is pure speculation on my part. We envision that there is certainly presentation of mandatory AEA content, as well as rich media content. The thought is that at least with the rich media content, everything that we're currently doing is probably going to support that content. We're defining video codecs, audio codecs, and all that good stuff, and we imagine that the rich media will be, well, video and audio and all that good stuff. With respect to the presentation of mandatory media, the only thing that I could come up with that might be something we need to work on in a particularly special way would be if the mandatory audio part of the EA, of the emergency alert message, needs to somehow be spliced with the with the program audio. Not sure about that, don't know, just an area of exploration. And then lastly, there's this notion that Jay showed you a screenshot of a program guide or a user interface, if you will, where the viewer can select some NRT content that might have been downloaded to their device. So where is that user interface going to come from? Is that something that ATSC specifies, or is it a receiver implementation thing? TBD, but these are the things that need to be on S34's radar. And if anyone in the room has other thoughts about what needs to be on our radar, please let us know. Thanks.
Thank you, Madeline. We have a demonstration out in the lobby, if you're interested, of advanced emergency alerting on a large screen display with actually the software processing for all that embedded in the receiver. So we're glad to take you through that. It has the banner alerts, has the guide, and some rich media content in support of the event. And with that, Jerry, can you, oh yeah, questions for the team? Yes, Art.
Yeah, on that, that demo, that's a higher level, or is that using the tentative conclusions on the physical layer of instantiation?
I believe it's using physical layer as well as route and dash for the delivery. Okay, any other questions? Okay, if not, Jerry, drive them home to the cocktail hour.
All right.